Welcome to the deep dive. You sent over this really fascinating set of research about kids' physical activity and how they think and learn.
That's right. And the core of it is this huge study from Educational Psychology Review back in May 2023.
Right, the multi-level meta-analysis of physical activity interventions during childhood. Quite a mouthful.
It is. But what's powerful is that it's a meta-analysis.
Mm-hmm.
So it's not just one study.
Mm-hmm.
It pulls together, let's see, 92 different studies
Mm-hmm.
over 25,000 kids aged about 5 to 12.
Wow.
And he uses some pretty clever statistical methods to see the bigger picture, to handle all the complexity when you combine lots of research like this.
Exactly. So our mission here is to kind of pull out the key stuff from this massive analysis for you, the listener.
Find the practical takeaways.
Yeah, because I think most of us assume, exercise is good for kids' brains, right? But this research, it shows things are a bit more nuanced.
Definitely more nuanced and, honestly, quite surprising in places. It's not like all exercise helps all thinking in the same way.
Okay, so those aha moments you mentioned, let's get into it. This study looked at all sorts of ways kids get active. When they took that first really broad look, what was the headline?
Well, this is one of the surprising bits. Looking across all those studies initially, they didn't actually find a significant overall boost for general executive functions.
Huh. So things like working memory, attention, planning.
Exactly, those. Or even for overall academic achievement, when just lumped together like that.
So maybe running around the playground doesn't automatically mean better focus in class across the board.
Not according to that first very broad look, no. But, and this is really crucial, that doesn't mean activity doesn't help.
Right.
It just means the picture is more complex. We need to dig into the specifics.
Okay, so that overall view was maybe a bit too simple. Where did they find positive effects when they looked closer?
Well, one area that really stood out was on-task behavior in the classroom.
Keeping kids focused on what they're supposed to be doing.
Exactly. They found what they called a large effect size there.
Yeah.
The number was G equals 1.04, which sounds great.
It does sound pretty big.
But there's a big caveat. The certainty of the evidence was rated very low.
Very low certainty. So, a potentially big impact, but we need to be a bit cautious about that specific finding.
Precisely. It suggests we need more consistent, high-quality studies on that specific outcome. It doesn't mean it's wrong, just less certain.
Okay.
What was interesting, though, was that a lot of the interventions showing this improvement actually mixed the physical activity with the academic work.
Like moving while learning.
Yeah, sort of active learning approaches.
Yeah.
Which intuitively makes some sense for keeping kids engaged, doesn't it?
It really does. Okay, so on-task behavior, potentially a big win, but needs more research. What else popped up?
Creativity was another one. They found moderate improvements there.
Creativity. Interesting. How much is moderate?
The effect size was G equals 0.70. Again, though, the evidence certainty was rated low.
Low certainty again. Okay. What kinds of activities were linked to boosting creativity? Not just jumping jacks, I assume.
Probably not. The studies often involve things like dance or what the researchers called enriched activity.
Enriched activities. What does that mean exactly?
Think less repetitive drills, maybe more imaginative stuff like movement games with storytelling or problem solving physically, maybe collaborative challenges, things that engage the mind and body in a more open-ended way.
Gotcha. So movement that encourages thinking outside the box, literally.
Kind of, yeah. It seems that cognitive engagement during the activity might be key there. Beyond that, they also saw small beneficial effects for fluid intelligence.
Fluid intelligence. Remind me, that's the problem-solving on the fly, thinking flexibly sort of thing.
That's a great way to put it. Solving new problems without just relying on what you already know. The effect size was smaller, 0.16.
Okay.
But the evidence certainty here was moderate, so a bit more confidence in this one.
And what kind of activities helped with that flexible thinking?
It was actually quite a mix. Things like holistic movement, maybe yoga or tai chi, dance, aerobic exercise, activity mixed with academics, and those enriched activities again.
So no single magic bullet activity for fluid intelligence, it seems. A variety might help.
It looks that way, yeah, which is interesting in itself.
What about memory? So crucial for school.
They did find small beneficial effects on working memory.
Yeah.
G equals 0.18.
Similar size to fluid intelligence then?
Yes, but back to very low certainty evidence for this one.
Okay, so caution again.
Right. And like fluid intelligence, the types of physical activity involved were pretty diverse across the studies.
Okay, so summarizing the positives. Potential big impact on staying on task, maybe moderate on creativity, small but maybe a more solid effect on fluid intelligence, and a small hint for working memory, but all with varying levels of certainty.
That's a good way to sum it up. And it's just as important to talk about where they didn't find an overall benefit in that big picture look.
Right. What areas were those?
So things like attention specifically, inhibitory control, you know, resisting impulses, planning skills, cognitive flexibility, like switching tasks.
Ugh.
And, as we mentioned, overall academic outcomes didn't show a clear benefit when just looking at everything combined.
That's really key, isn't it? That exercise makes you smarter idea is maybe too broad. It didn't necessarily translate directly to better overall grades in this
Not
analysis.
in that initial combined analysis, no. Which leads us perfectly into the next part, which I think is where it gets really practical.
The specificity, like, does the type of exercise matter or how long you do it for?
Exactly. The moderator analysis. This is where they slice the data differently. Does the type, duration, intensity, frequency, does any of that change the results for specific outcomes?
This feels like where the actionable insights might be. What did they find? Let's start with academics, maybe math.
Okay, for math, yes. They found that physical activity that was specifically integrated with academic instruction seemed to help math outcomes.
Ah, so not just PE class, but doing math while moving.
It seems so. And particularly interventions that lasted between 6 and 10 weeks and used moderate or moderate to vigorous intensity activity.
That's quite specific, like active math games or something.
That's the kind of thing, yeah. It suggests that linking the physical action directly to the mathematical concept might be what helps cement the learning there.
Okay, interesting. What about language? Did integrating activity help there too?
For language, it was slightly different. It wasn't necessarily the direct integration that stood out, but rather those enriched PA programs.
Those creative, possibly more complex activities we talked about earlier?
Yeah, there's probably overlap. Things that might involve more varied tasks, maybe more communication, imagination, using language within the activity itself. It seems that broader cognitive engagement through movement might benefit language.
So a different approach seems better depending on whether it's math or language.
Oh.
Fascinating. What about those executive functions like attention and control that didn't show an overall benefit? Did specific activities help them?
Yes, this was another key finding. It appeared that aerobic physical activity, the kind that gets your heart rate up, moderate to vigorous intensity, seemed to benefit executive function outcomes.
Ah. So maybe the more traditional running around, getting breathless type of exercise is good for things like focus and self-control, even if it wasn't obvious when looking at all activity types together.
That's what this suggests, yes. It really highlights how the type of activity can target different brain functions. Aerobic for executive functions, integration for math, enrichment for language, maybe.
This paints a much clearer picture, doesn't it? It's not just move more, it's move smart.
Exactly. But we still need to keep some important caveats in mind.
Right. You mentioned things like variability between studies.
Yeah, high heterogeneity, they called it. Basically, the results varied quite a bit from study to study, even when looking at the same outcome.
So what works perfectly in one school might work slightly differently in another.
Could be. It depends on the kids, the teachers, the exact intervention. Context matters. We can't just assume one size fits all. This meta-analysis also tried to improve on past ones, using better stats and looking at more types of outcomes, which is good.
And what about the why? Did they talk about why movement might help the brain?
Briefly, they mentioned a few theories. One is neurobiological exercise changing the brain itself, like growing connections or increasing blood flow.
Makes sense.
Another is skills acquisition, complex movements, challenge the brain and build cognitive skills indirectly. And then there's embodied cognition, the idea that our body and mind are deeply linked, so moving affects thinking.
So it could be biological changes, skill practice, or just that deep mind-body link, maybe all three.
Quite possibly. It's likely a combination.
Now, thinking practically again about schools or parents trying to use this, did the researchers highlight anything important for implementation?
One point was about teacher qualifications. There was some hint that teachers with more specialized training in, like pedagogical approaches to physical activity, might get better results.
That makes sense. Knowing how to integrate movement effectively probably matters a lot.
Absolutely. They also looked at the comparison groups in the studies, like was the activity group compared to kids doing nothing or kids doing normal PE?
Did that make a difference to the results?
Interestingly, not really. The type of control group didn't seem to change the main conclusions much. It suggests the benefits were likely from the specific interventions themselves.
Okay, so the specific programs seem to add something beyond just regular activity levels. And how did they measure things like creativity or attention? Must be tricky.
Yeah, they used a whole range of tools, standardized cognitive tests, academic tests for math and language, teacher reports, observations of classroom behavior. It varied across the 92 studies.
Which probably contributes to that heterogeneity you mentioned.
Exactly. And that brings us back to certainty and something called publication bias. You asked about that earlier.
Right. The idea that studies with positive results get published more often.
Yes. And the researchers did find signs of potential publication bias for some of the positive findings, specifically for fluid intelligence, on-task behavior, and working memory.
So the positive effects seen in the published research for those areas might be slightly inflated because studies that found no effect might be missing.
That's the potential issue, yes. It doesn't mean the effects aren't real, but it might mean they're not quite as strong or consistent as the published literature alone would suggest.
Which is why those certainty ratings, the very low to moderate using that grade system, are so important to keep in mind.
Absolutely. It's about being transparent about the strength of the evidence. Promising findings, yes, but we need ongoing research to be more certain.
This has been incredibly insightful. It really unpacks that simple exercise is good for kids idea into something much richer and, frankly, more useful. So, thinking about everything we've discussed, what's the big question or thought you'd want to leave our listeners chewing on?
Well, given that it seems different types of movement, structured in different ways, might target very specific thinking skills or academic areas,
Yeah.
it really makes you wonder, doesn't it?
Wonder what specifically?
How can we educators, parents, policymakers be more strategic about this? How do we move beyond just more PE and start thinking about which activities, integrated in which ways, might best help kids develop particular skills?
Like designing movement breaks specifically to boost attention or embedding certain types of active games into math lessons.
Exactly. What follow-up questions does this research spark for you, the listener, about optimizing movement for learning? It's not just about quantity, it's about thoughtful quality and integration.
That's a fantastic point to reflect on. So just to quickly wrap up our deep dive today, the big takeaway seems to be that while physical activity isn't some kind of universal fix,
It can definitely be a valuable tool, especially for things like creativity, keeping kids on task, maybe fluid intelligence.
but the type of activity, the intensity, how long you do it for, that really seems to matter based on that moderator analysis.
Absolutely crucial. Aerobic for executive functions, integrated for math, enriched for language. Those were the interesting hints. Tailoring the activity to the goal seems key.
So for you listening, think about how this connects with what you see. Does it spark ideas for schools, for home? How could we apply this more deliberately?
We really hope this dive has given you a good handle on this complex research, maybe some surprising insights, and definitely some food for thought.
Yeah, and if you're really keen, do check out the original study. There's always more detail, but hopefully this gives you a strong starting point.
Definitely. Thanks for joining us on the deep dive.